Hello, Secretary Honor. Hope you are all doing well. This is the another video with the same chapter number 11, acids and bases. In this video, I have covered the topic bases and alkalis. You can refer this topic from your textbook, page number 119 to 194. In the previous video, you learnt about the definition of acid. I recall an acid is a substance that produces hydrogen ions, that is H plus, in aqueous solution. In the same way, there is another substance called base. A base is any metal oxide or metal hydroxide that reacts with an acid to produce a salt and water only. Okay, so I repeat again, a base is any metal oxide or metal hydroxide that reacts with an acid to produce a salt and water only. You should understand the word metal oxide or metal hydroxide. Let me explain you little about metal oxide and metal hydroxide. What is a metal oxide? Any metal with oxygen is metal oxide. You should be knowing by this time that group 1 elements, group 2 elements and group 3 and also the transition elements from the periodic table are all metals. Okay, so if you see the example of metal oxides, I have written just 3 examples. There are many. Magnesium oxide, copper oxide, zinc oxide. Okay, so magnesium, copper, zinc are all these are metals. Okay, so any metal with oxygen is metal oxide, and you should be knowing the charge of oxygen, O2 minus. Okay, O2 minus, because oxygen belong to group 6, the charge of group 6 is -2. Okay, what are metal hydroxides? Okay, metal hydroxides, you should be knowing the symbol for hydroxide ion, OH minus. Okay, so any metal with hydroxide ion, that is OH minus, is metal hydroxide. If you see the example, NaOH, KOH, CaOH twice. Here sodium, potassium, that is Na, K is potassium, calcium, Ca. So all these three are metals. So they are combined with hydroxide ions, OH minus. Okay, so when you combine Na plus OH minus, we get sodium hydroxide. In the same way, K plus OH minus, so we get potassium hydroxide. And calcium hydroxide, Ca2 plus and OH minus. I will show you the equations for this. Before we understand the equation, let me tell you what is an alkali. Okay, what is an alkali? So there is a little difference between a base and an alkali. Okay, the definition for alkali is a substance that produces hydroxide ion. Okay, you can see the symbol for hydroxide ion, OH minus. There is a minus charge above oxygen. So a substance that produces hydroxide ion in aqueous solution. So this is the definition for alkali. Now look at these equations. Example, sodium hydroxide in aqueous state. When we dissolve sodium hydroxide in water, Na becomes Na plus, OH becomes OH minus. Okay, why there is plus charge on sodium? Because it's a metal and sodium belong to group 1. So all group 1 elements will get positive 1. If you see the next example, calcium hydroxide, when we dissolve calcium hydroxide in water, it gives out Ca2 plus aqueous. Why do we write 2 plus? Because calcium belong to group 2. The charge for group 2 elements are 2 plus. So I have told you many times, the metals, they have the tendency to give out electrons. So group 1 elements, group 1 metals give out 1 electron from the outer shell. Group 2 will give out 2 electrons from the outer shell. So that's why calcium gets 2 plus charge, because it belongs to group 2. Now there is another example wherein we add ammonia gas with water. Water is in liquid state, yeah, don't forget that. So when we add these two, ammonia and water, we get ammonium ion and hydroxide ion. Okay, these are the 3 examples from which you can understand that In all these three examples, we are getting OH minus, OH minus, OH minus, right? So it means these three substances are called alkalis. These are the examples for alkalis. There are many other examples. Let's move on further with the properties of alkalis. We learned about the properties of acids in our previous video, right? Now, there are just 5 properties of alkalis given in your syllabus for IGCSE. 3 are shown here. As you know, acids sour taste, right? The taste of acids are sour. In the same way, alkalids have bitter taste. So you should understand, you should remember the difference between acid and alkali taste. Acid taste sour, whereas alkali taste bitter, and we can feel it soapy. Okay, it will be soapy. Usually alkalis are added in soaps, detergents that we use in our daily life. Now the second property is alkalis turn red litmus paper to blue, whereas acid turns blue litmus paper to red. Whereas but in case of alkalis turn red litmus paper to blue. Now the another property of alkalis, they react with acids to form a salt and water only. If you see the general equation that I have shown, alkali plus acid combines to give just two products, only two products, salt and water. With an example, you can understand much better. Alkali, the example for alkali, sodium hydroxide NaOH plus hydrochloric acid HCl. They combine to give sodium chloride, that's a common salt that we use in our food, and water. So this reaction is called neutralization reaction. There is one more question. What is a neutralization reaction? A neutralization reaction is a reaction in which the hydrogen ions, that is H plus, from the acid and the hydroxide ions OH minus from the alkali reacts to form water. If you see the equation, the half equation, the ionic equation, H plus OH minus combines to give H2O liquid. Okay. The fourth property of alkali. Alkalis, when heated with ammonium salts, give off ammonia gas. If you see the example, calcium hydroxide, it's an alkali. Ammonium chloride is a salt. Okay. When these two combine, we get a salt, calcium chloride, water, and ammonia gas. Okay. I will give you many examples in some other different worksheet after this video. Now move on to the next property, that is the fifth property of alkali in your syllabus. Alkalis react with a solution of one metal salt to give another metal salt and metal hydroxide. If you see example, sodium hydroxide is an alkali. Okay, ferrous sulfate or iron 2 sulfate, we can say iron 2 sulfate. Fe is iron. Okay, so it's a salt solution. Iron 2 sulfate is a salt solution. When we mix sodium hydroxide, that is alkali, with a salt solution, we get another salt and another alkali. Okay, so what is that another salt that we get? Sodium sulfate. And what is another alkali we get? Iron hydroxide. Okay, so move on to the uses of bases and alkali. You can refer the textbook page number 193. Okay, so there are just 4 uses given for bases and alkali. Please refer your textbook to study this. Uses you need to memorize. Okay, so I hope this video is helpful to understand about bases and alkalis. Meet you in the next video.